Hey there, data enthusiasts! Welcome back to our channel. If you're passionate about machine learning and want to take your models to the next level, today's video is just for you. We're diving into the world of grid search in model optimization. So, grab your favorite beverage, sit back, and let's get started. Now, you might be wondering, what exactly is grid search and why is it so important for optimizing models? Great question! Let's break it down. At its core, grid search is a method used to fine-tune the hyperparameters of machine learning models. Hyperparameters are the settings or configurations that you can adjust to optimize the performance of your model. Think of them as the knobs and dials that can help you get the best possible results. But why should you care about hyperparameters? Well, the choice of these settings can significantly impact your model's accuracy, robustness, and overall performance. A well-optimized model can mean the difference between a mediocre result and a model that truly shines. So, let's say you're working with a decision tree classifier. Some of the hyperparameters you might want to tune include the maximum depth of the tree, the minimum samples required to split an internal node, and the minimum samples required to be at a leaf node. Each of these settings can lead to different outcomes when it comes to your model's accuracy. Now, imagine you want to find the best combination of hyperparameters for your model. This is where grid search comes into play. With grid search, you define a grid of hyperparameter values that you want to explore. For instance, you might want to test maximum depths of 3, 5, and 10, and minimum samples of 2, 5, and 10. This creates a grid of combinations that the model will evaluate. So, for our example with a decision tree classifier, grid search would evaluate these combinations systematically. It will train and validate your model for each combination, measuring the performance using a metric like accuracy or F1 score. The result is a comprehensive assessment of how different hyperparameters influence your model's performance. Let's look at a concrete example. Imagine you are trying to classify images of cats and dogs using a support vector machine. You set up a grid search with the following hyperparameters: kernel types, linear and RBF, and regularization parameters of 0.1, 1, and 10. Grid search will evaluate all combinations, so you'll train the model with a linear kernel and regularization of 0.1, then with a linear kernel and 1, and so on. This ensures you don't miss the best possible settings for your model. After running the grid search, you find that the RBF kernel with a regularization of 1 yields the highest accuracy. Now you've identified the optimal parameters for your model. However, it's essential to note that while grid search is powerful, it can be computationally expensive, especially as the number of hyperparameters and their possible values increase. This is often referred to as the curse of dimensionality. To mitigate this, you can use techniques like random search, which samples a subset of hyperparameter combinations instead of evaluating every single one. In addition to being computationally intensive, grid search may also lead to overfitting if not done carefully. That's why it's crucial to use cross-validation, a technique where you divide your dataset into multiple subsets to ensure your model generalizes well to unseen data. To sum it up, grid search is an invaluable technique for optimizing the hyperparameters of your machine learning models. By systematically exploring combinations of parameters, you can enhance model performance, leading to better predictions and insights. So, there you have it! Grid search is a straightforward yet powerful approach to model optimization. If you're looking to boost your machine learning game, I encourage you to try implementing grid search in your projects. If you found this video helpful, please give it a thumbs up, subscribe for more content like this, and hit that notification bell so you won't miss our next deep dive into data science. And as always, drop your questions or experiences with grid search in the comments below. We love hearing from you. Until next time, keep exploring the fascinating world of data.